Alright, welcome back again. I hope you had some fun playing around with print statements in Python, just kind of seeing how they work. Now we're going to get into a little bit more advanced programming. For this part, I will be going back and forth between slides and code like I did in the previous video. You are welcome to follow along and type with me as I go. You're also welcome to just watch, and then basically at the end of the slides I'm going to ask you to go back and type in all the things and follow along. One way or another, you will be typing in the content on the slides and just making sure that it all works for you. Some people like to follow along with the lecture, and some people are like, let me just pay attention now. Do whatever works for you. There's no right or wrong way to do this. All right, let's go. So we're going to start writing some simple Python stuff, programs, creating variables, writing output, and getting input from users. So we already did printing, right? You can print a whole bunch of things. We did hello world, and you can print some other statement. So, this is maybe something like what you did after the end of the last video. Yeah, basically the point here is I'm saying programming is fun, but just printing is kind of limited. There's not all that much you can do just with a print statement. So we're going to teach you some other things. So one of the key components to any programming language is variables. Variables let you store information and then use it later, or use it repeatedly. So for example, I can say name equals Amber. Notice the quotes around that name. And then I can print hello, like I did before, again with the quotes. We'll talk about what the quotes mean in a little bit, and just accept them for now. And then I can say print and then name. You'll notice name is not in quotes. And what will happen when we run that, what's going to happen is, I'm going to save it, and I'm going to run it, and it'll say hello, and then it'll say Amber. So that's because the value Amber is being stored in what's called a variable that I'm calling name. If I had put quotes around name and then saved it and run it, what would happen is it would say hello and then name. So basically anything in quotes is exactly what you want to be typed. But then if you have something not in quotes that has already been defined, like name here, that means it's storing some kind of a value, and Python will say, okay, let me go check to see what that value is, and plug that in. Variable names, there are some limits on what you can call them. Basically, you can do things like, first and then capital N name, that's called camel case. Last underscore name to, help differentiate it. People have preferences. I like the underscores. I personally think it makes things easier to read, but you can also do things like name one. You can just use name like I did. You cannot, however, start a variable name with a number or a character like an exclamation point. In fact, you can't have any special characters except for underscores and I think hyphens. I actually don't remember. In Python variable names, you cannot have spaces in them. It's basically stick with underscores. That is safest. When it comes to naming variables, you can name variables anything that you want. I could go back to the code that I just wrote and say, name, that's so obvious. I don't want to call it that. I'm going to call this, I don't know, Pikachu. And then I'm going to change this down here, Pikachu. And it'll still run, and it'll still give exactly the same output because I changed it in both places. That's important. But future me is going to come back and look at that code and go, what? What is Pikachu? What does that even mean? What is that doing here? Why would I have done that? That's silly. So it's strongly recommended as a programmer that you pick names for variables that describe what they're doing. So let's undo that and go back to name. In terms of valid names, safest thing to do is just stick with lowercase, uppercase letters, underscores, and that's pretty much it. Okay? Alright. So, Um, Basically, I already covered that. Oh, one other thing that is really important, you can't name variables after things that already exist in Python. Those are called reserved words. So the only one you've seen so far is print, but you don't want to have a variable named print, because then when you go to actually try and print something, Python's not going to know what to do, and you're going to get just weird error messages. So don't do that. Keep the names, you know, descriptive, but if you find yourself, basically, this is where that syntax highlighting is going to really come in handy for you again, because you notice how print here is in purple. Other words that show up in purple, that is idle's way of telling you, hey, this is something Python already has a definition for, that is already a part of the language. If you ever see that purple on the left side of an equal sign, you know you've done something kind of wrong, that you're about to potentially break things in like a really not good way. So keep an eye out for that, and just don't have purple be on the left of that equal sign, because that means you're assigning some kind of a value to something that Python actually needs. Okay. So I keep using the word strings here and there, and basically a string is just anything surrounded by quote marks is a string, and strings can contain any type of character. So you can do name, and then in quotes, whatever, age in quotes, all kinds of special characters in quotes. Looks like I'm cursing there. So whatever you want, as long as it's in quotes, it's called a string. Sometimes a string literal, but it's a string, and it just says, like, Python, here's what I want you to type. Anytime you see the variable, I want you to plug in that information that I just gave you, and it will. You can also have integers. So integers are numbers without decimal places, so basically whole numbers. And you can do math with them. So here I can say things like num underscore apples equals 12. Num underscore bananas equals 7. She's got 7 bananas. You can see how much easier this is to read than if this said, like, you know, Vulpix and Ghastly. Yeah, I know a lot of Pokemon names, don't judge. You know, so what does that mean? I don't know. But num apples and num bananas, that makes sense. I see what's going on here. So if I want to know how much fruit I have in total, I can say all fruit equals, and then num apples plus num bananas, and that will give me the answer. And then I can print all fruit, and that will print the total number of fruit that I have. The main thing to keep in mind here is that I've already referred to having variable names on the left. That will always be true. Anytime you're creating a new variable or giving an old variable a new value, because that is also something you can do. The variable name goes on the left, and then the value, and then there's an equal sign, and then the value goes to the right of the equal sign. This is just like all the math you've done in math classes, so we're not trying to trick you or do anything crazy here, but always think variable left, value right. So integers are cool, whole numbers, who doesn't like those, but sometimes you want to do things with decimal points, and that's actually called a float for floating point integer. So they're decimal numbers, basically, not whole numbers. So you can also do math with them. Huh? Who knew? So you can say things like price equals $12.99, tax equals 0.07, and then the total, here I have price, total equals price plus price times tax. And then when you print the total, it will have the correct amount. So one thing to note is that both integer and float math follow the PEMDAS rules, right? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. If you're like, wow, I did not see that coming back in grad school for library science, surprise. It's we're not going to be doing a lot of math for this, I promise, but I just wanted to let you know that in fact that will come up. So if you do need things to be done in a particular order, you are going to have to use parentheses or be very careful about how you type out your math. So yeah, basically that is how, those are the three main types of variables that we're going to be using. Strings, integers, and floats. So, the thing about variables that I've shown you so far is they all rely on I've been giving the variables their values just straight off the bat, right? I'm like, name equals Amber. Okay, that's fun. But one of the reasons we need programming languages is that we want to be able to interact with information that maybe wasn't there previously, right? We want to ask the user, hey, what's your name? You know, what do you want me to calculate for you today? So we do that, so programming languages have built-in ways to ask users for information. In Python, we do that by using this input function. And then if you use input, like I have here, so I have name equals input, and then in quotes, what is your name? So this looks a lot like a print statement, except we replace print with input, and now we're assigning whatever comes back from this input thing into name. So that should say default, sorry about the typo there. Let me show you what I mean. So if I go into the code and I say basically what's on there, so name equals inputs, what is your name? I can save it, run it, and what happens is you'll see how the shell pops up. It might not pop up, you might have to bring it up yourself, but it should be there somewhere. And now in that shell, it's asking what is your name, and there's a blinking cursor. So after that question, I can type, well, my name is Amber, and I hit enter, and then it says my name back to me because I told it to print my name. So you can see, okay, well, now this is getting a little bit more interesting. Now we're getting input from someplace else. The program is still predetermined. It's still going to ask for a name and it's going to print that name, but we don't know what the name is. So that makes it a little bit more interesting. So one thing to be really aware of is that this says on the previous slide, so all input is stored as strings by default. And that's important to remember because if you do want to do math, with something that someone tells you, you have to convert something from a string into the type that you want it to be. So for example, if I want to ask someone's age, I still use input, I still use the string, you know, I have the parentheses and I have the quotes around the string that's the question that's going to ask the user, which is really important because the user's not going to know what to type unless you tell them what you're asking, right? So that input question there is really important. But around that, I have the word int and then another set of parentheses. So the parenthesis for int starts here and then it ends all the way at the end of the line. And basically what that's saying is take whatever the user types in and turn it into an integer. This will not work if the user types out, you know, 31 or whatever in actual words. Python cannot deal with that. But assuming they are kind and they just type in the digits 3 and 1, Python will say, okay, cool, I know what to do with that. That is now an integer. Basically, same thing with the price. So price equals, and then instead of int, I use float because prices are often not in whole numbers, right? They usually have like 5 cents or something tacked on. So let me show you real quick what I mean by doing the conversions and things like that, because I want you to see what happens if it doesn't work or if you do it, I don't say wrong, but if you make a slight error in what you're trying to do. So let's look at the price thing. So this is kind of similar to what was on the previous slide. So I'm going to ask for the price. I'm going to say total equals price plus price times 0.07. So I'm not storing the tax in a separate variable, I'm just putting it in there. And then I say print total. What does it cost? Okay, so I save that and I run it. And then I say, okay, well, it's $12.99. I still get the error message because $12.99 is still a string, right? You can have any kind of information in a string, including the digits 12, the decimal point, you know, the period, and then 99. That's a string unless I tell Python otherwise. So that's where I need to then do the float parentheses, and then go to the end of that line and put the end parentheses. I know I'm kind of going off the screen here, but hopefully you can see what's going on. See the whole thing. Okay. So now if I run it, save it, run it, what does it cost? $12.99. Okay. So now Python was able to say like, oh, okay, I know how to do all that. So what it's doing is it's going in and saying like, well, price, okay, let me go fetch whatever number that person typed in, and then add it to the price times 0.07, and that's the total, and then I print that. So hopefully that gives you a sense of like how you would get input from a user but then still use it in a way that's useful. I said use a lot right there, but you know what I mean. What I want you to do, if you haven't done it already, like I said, go back through the slides, type out the code from the slides into a Python file, make sure they run, make sure you're typing them correctly. I'm pretty sure there aren't any errors in the slides, I hope. If there are, that'll be an interesting learning experience too. Putting comments so that you remember what each of the lines does, and I actually really recommend that you save that file separately somewhere as, you know, whatever the week is, Python practice 1 or something like that, so that you can go back and look at that file when you're doing the homework for this week or the homework for next week and say, okay, well, I did something kind of similar. How did that work? What did that look like? And then you can go back and look at that file instead of having to go back through the slides and you know, rewatch the entire video. That can be a reference that you can easily copy and paste from. All right, have fun.